Well, thank you, Russ. It's a real pleasure to be here and to be able to really provide a presentation which I hope will set up the other speakers as we go through this two-day session. What I want to talk to you about is what do we know about the role of physical activity in reducing obesity? You all see this, right? You see Time magazine, where I get a lot of my information, says the myth about exercise. Exercise really isn't doing that much for you. So we sit in the audience, and I feel like I'm kind of preaching to the choir here. You sit in the audience and say, well, that's the media. They just want to sell newspapers and sell magazines and so forth. You can't really pay much attention to that. But then you look in the literature and you see scientific peer-reviewed publications say physical activity does not influence obesity risk. It's time to clarify the public health message. And one of the arguments, and I want you to keep this in mind, we're going to come back to it, so well, the changes in physical activity happened a long time ago. That's sort of past, that's over. Food's driving the bus right now. And so as we go through, is that right? Should we be debating whether or not physical activity is important in obesity or not? And so I wanted to go back to my roots. Oh, I'm sorry, here, I wanted to give you one more. And here's another one you often see is you can consume a large burger in 3 minutes, and you can consume 560 calories, but it takes you a long time to burn it off. So physical activity can't be that important, right? Okay. So this is the setup I want to take us through. What do we know about this? Are we still lacking evidence that physical activity is important in obesity, or are we not? So I go back to my roots, which is the science of energy balance, and people say, oh, energy balance, that's boring, calories in and calories out. I think anything that affects obesity has to work through this system. Now, this is a very complex system because the components are interrelated. You change any one thing, everything changes. Also point out this box called active regulation. There's a whole physiological system from the brain on down to regulate body weight. And we know that there are a lot of things that affect this. It's affected by inherited factors. It's affected by environmental factors. So what I want to consider this morning is what do we know about physical activity? How does physical activity, adding or subtracting it to the system work? What science do we know? What science do we not know? So let's start out with energy stores. We store energy as fat and muscle and so forth. So what do we know about the role of physical activity? Well, lots of studies show a relationship like this. Here's VO2 max as a measure of physical activity or fitness. And this is our work, but lots of other people have shown that those people who are more fit, more active, are leaner. They have lower body fat, okay? That's cross-sectional. There's also some data, and I think John Jakizek will probably talk about this later on, that if you're in a weight loss program, adding physical activity may or may not affect weight loss, depending on the amount of physical activity, but it affects the composition of the weight loss. So a little bit more fat lost and a little bit less with physical activity. So there's some pretty good, at least associational evidence that physical activity can affect the composition of the energy we store in our body. So what happens then to this system if we add physical activity? So if you tell me that you're going to do a study and you're going to take a lot of subjects and you're going to increase physical activity and you ask me to predict for each individual what happens with body weight, my prediction would be you could get an increase, you could get no change, or you could get a decrease. It depends. What does it depend on? It depends on compensation. So one of the other ways to think about it, if I get you to be physically active, how can that not affect your body weight? Well, you could be more sedentary in other times. So I could add an hour a day of exercise. You could decrease your usual activity for an hour. The other way is I add an hour's worth of exercise, you simply compensate. You eat that many more calories. So from what we know about energy balance, any of these outcomes can be explainable. And one of the things is we have to measure these in order to know that. And oftentimes we do the studies and we measure weight and we're curious on why some change and some don't. But if we measured energy balance, I think we would understand that. So again, here, the question is, does this change or this change? Well, we have some evidence out there. Here's a systematic review from last year in Joe Donnelly's group, and they looked at all the evidence they could find, which isn't a lot. It's like 30 studies. But what they concluded, they were looking at if you have people exercise, are they sedentary to compensate for that? And again, they found strong evidence that that wasn't the case in most studies. In 100% of cross-sectional and RCTs, increasing physical activity didn't lead to compensation. In other words, it didn't lead to people being more sedentary. Now, they pointed out these aren't a lot of studies, so certainly we need more data. But the evidence we have strongly suggests that when you add exercise, people don't compensate, at least completely. So the net impact of adding exercise is you get a total increase in energy expenditure. That seems to be the case in most people. So now the question is, well, do you simply eat more? And that's what the Time magazine article, if you look at that article, what they said is, it's the myth of exercise, because when you have people exercise, they simply eat more. So in the long run, you don't have an effective exercise. But we have a fair amount of data on this, and I apologize, I'm giving you an overview. If you want to go into more detail on some of these, I'm happy to do it. A meta-analysis here in April 2012, variability among studies, but strongly suggests that exercise is effective for producing a short-term energy deficit. Individuals tend to not compensate for the energy they spend in exercise by eating more, okay? Now, I want to show you one particular study because I think John Blundell's really been a pioneer in this area, and I really love the kinds of studies that he does. And here's one study where what they did is they took a group of overweight, sedentary people, and they put them through a supervised exercise program. And here's what happened to their body weights. You can see that some people gained weight. The food intake wasn't controlled here. Some people gained weight, some people didn't change, and most people lost weight. Just like I told you in the previous slide, my guess is that any of these things could happen, and in fact, if you look at any of these studies, that's what you find when you add exercise. Some people lose weight, some people don't change, some people gain weight. Now, what I want to point out is the vast number of people here lost weight. So if you're saying, boy, look at the people on the right, it suggests that exercise causes you to gain weight, you would be ignoring the body of evidence. And most of the other studies that have done this find the same thing with the fact that most people lose weight. So Blundell's group went back in a follow-up study and said, what's different about those people who are gaining weight versus those people who are losing weight? Gee, it was a shocker. What he found is they ate more. The people that gained weight actually increased their energy intake. The responders actually decreased a little bit. So it totally fits. There's no magic here. When you give people an exercise program, most people will lose weight, some people won't change, a few people will gain, and it totally depends on their compensation. But based on this, what we would have to conclude is that for the majority of people, and we're going to come back and visit this a little more, for the majority of people, at least from studies in the literature, when you add physical activity, there is not complete compensation for that increased energy expenditure, either in being more sedentary or eating more. Net result is adding physical activity produces negative energy balance. That may vary in individuals. Some people lose more, some people lose less. But it's wrong to say that people simply compensate for exercise. It has no effect because people eat more. Most people do not. So what happens if we decrease physical activity? Is decreasing physical activity a risk for weight gain? Well, one of the problems in doing these studies is most of the time we look at decreasing physical activity in those people that are already pretty sedentary, okay? But again, we do have some data here that would help us. And this is data from James Stubbs back in the late 90s. There's really a lot of good energy balance science back in the mid-late 90s. What James did in a whole room calorimeter is he simply looked at what happens in the calorimeter if you decrease people's energy expenditure. And what he was interested in, if you decrease their energy expenditure, do they simply compensate and eat less? A reduction in physical activity wouldn't be a risk factor for weight gain if people simply eat less in response to physical activity. But what he found is that, in fact, when people were active or sedentary, their energy intake wasn't very different, because now their sedentary energy expenditure is lower. They were in positive energy balance. Now again, this is a short-term study in a calorimeter, but I think there's a fair amount of evidence out there suggesting that when you decrease physical activity, at least in most people, they don't immediately decrease their energy intake to adjust, suggesting that decreased physical activity likely is an important risk factor for weight gain. And the other place that I think is really where the action is in how physical activity affects not expenditure or intake, but how it affects the active regulation of energy balance. So, what is the active regulation of energy balance? Well, in the last decade or so, amazing science to identify all this circuitry in the brain that regulates food intake. Started with the identification of leptin, but then people took leptin and traced those pathways, and now you have models like this, where it really shows the importance of brain areas in sort of regulating energy balance. And so what we know is that physical activity can affect this. Physical activity and fitness affects the brain regulatory system. Lots of information about specifically how, but a neural regulatory system for body weight is different in active versus inactive people. So part of the way physical activity can affect active regulation is by affecting brain systems. The other way is what happens in the muscle, and Russ alluded to this a little bit. What we know is there are big changes both in the structure and function of skeletal muscles when we add physical activity. So the muscles of a sedentary person are acting very differently than the muscles of an active person. One of the concepts that I think really is important in the active regulation is the concept of metabolic flexibility and inflexibility. Now, metabolic flexibility is basically the ability to switch efficiently between fuels. So during fasting, if you have a flexible metabolism, you quickly suppress glucose oxidation and you increase fat oxidation. In a metabolically inflexible person, you have a blunted preference for fat oxidation. Now, during feeding or insulin-stimulated conditions, if you're metabolically flexible, you suppress fat oxidation, good at glucose oxidation. If you're inflexible, it's blunted. So it's a little bit of the rounding of the curves as you switch from fat to carbohydrate as a fuel. And this is important because here's work from Audrey Bourguignon in our lab showing that metabolic flexibility is directly related to physical activity. So the concept here, I think, is that metabolically flexible is the way your metabolism came out of the factory. It was ready to go, and it was metabolically flexible. The way you get inflexible simply is to quit moving. And simply losing weight does not necessarily increase metabolic flexibility. And I think that's one of the reasons why weight loss without physical activity is difficult to maintain, because you get the weight off, but you don't increase the metabolic flexibility. So metabolic flexibility essentially sets you up for weight gain. If you're metabolically inflexible, doesn't mean that you're going to gain weight, but it means that you're at a risk to gain weight depending on your behavioral, your food intake patterns. So you're a little bit more susceptible to store more fat rather than burn it. And these are small things over time, so it's perfectly possible to be metabolically inflexible and not be overweight, but you have to be very, very vigilant with food intake. So So to put it all together, I go back to a cartoon from John Mayer, who I really think understood how this energy balance system regulates. So Mayer's concept is there's a threshold of physical activity. For now, it's sort of a theoretical threshold. And above that is what John Blundell has called the regulated zone. And below that is what he called the unregulated zone. So let's look at the regulated zone. So once you're above this, as your physical activity increases, what happens? Your energy intake increases and your body weight stays the same. So again, if this is correct, what it would suggest, if we do studies in this population where we increase physical activity, what we should see is a total compensation of energy intake. So it suggests that we've got to look at our population as we're doing this. It also suggests there's some feedback between physical activity and food intake. So again, Mayer would say in this regulated zone where people are physically active and physically fit, your body is working for you to match intake and expenditure. And the other way I look at it is in this scenario, physical activity is really driving the bus and food intake is moving along. And I think this is the way our bodies work best. Now let's go down to the unregulated zone because it's very different. Here, as you decrease physical activity, you actually increase food intake. So there's not a very tight coupling between food intake and physical activity. Now the sad part is this is probably where most of the world is, down here in the unregulated zone. And it looks very much like food intake is driving the bus. It looks like food intake is important, physical activity isn't so important. And that's why I think you're getting people writing papers saying it's all about food. Physical activity decreased decades ago. It can't be relevant. What I would argue is that decrease in physical activity that got us in this zone to where now we're not very good at regulating energy balance, and it looks like food intake is driving the bus. So if you were able, and this is theoretical, I think we're getting more and more data to support it, but if you were trying to solve this problem down here, first step would get people into the regulated zone. And what I'm not saying is that it's all about physical activity. I think food intake is critically important, but I think if you're going to be down here, it's very difficult to come up with any single diet that's going to maintain weight in most people. And so an increase in physical activity is necessary, maybe not sufficient, but necessary if we're going to get people back to the level of regulating energy balance at a healthy body weight. So no question that physical activity has decreased, and maybe a lot of it was decades ago, but it's still continuing to decrease. Here is occupational caloric expenditure. You can see that it's decreased 140, 120 calories a day. That's enough to explain most of obesity itself. Trends in housework, I really like this one. So here's women, they've gone down. Men have gone up. So I think men doing housework is the cause of obesity. And I think we've got a solution to this, right? But the concept is we are continuing to get physical activity out of our lives. I believe that it was probably post-World War II where most of the decrease in physical activity happened, and that affected the active regulation. But it's still going down. And if you look around the rest of the world, China, for example, is experiencing this very, very quickly. So everything we know about the science of energy balance suggests that this trend is a risk factor for weight gain. And you're going to hear more about that, weight gain, physical activity and weight gain from our presenters this morning. Now, can physical activity prevent, weight gain? A couple of studies that I'll show to present this. Every study that's ever been done where they've combined a high palatable energy-dense diet and physical activity shows that there's less weight gain when you add physical activity to that diet than that diet alone. And here's simply one showing low fat, medium fat, high fat, sedentary, no change, gain, gain. You add physical activity, you can see that in every single condition, physical activity sort of opposes the weight-producing effects of the palatable diet. I could show you hundreds of studies that show the same thing there. The other thing is if you look at, can physical activity affect a genetic susceptibility to weight loss? Well, the FTO variants probably are some of the strongest genetic predictors of weight gain. There are a lot of genes involved. This one is fairly strong. But what this group found is that in people that had the FTO risk allele, the odds of obesity is attenuated by 27% in physically active adults. So again, I think we have very strong evidence that whatever is happening on the genetic side or the diet side, adding physical activity can mitigate the increase in obesity or weight gain through those two effects. And I think one of the best ways to look at how powerful a factor is in obesity is how does it push back in a weight gain, high-risk weight gain scenario. And in these two cases with diet and genes, physical activity strongly pushes back. Can physical activity help treat obesity? And John Jakisik is going to go into this in detail. I'll just give you one slide from our lab. We coined the term energy gap back in the early 2000s. And we get this data from putting people in a calorimeter. Kong, who's here, and Kevin Hall and others have models that show that. But basically, when you lose weight, your energy expenditure goes down. Why does it go down? Because you're eating less, you have a smaller body, you're losing muscle mass, you're losing body weight. And in our work, we would suggest that if you were to take about a 100-kilogram person, and you had them lose 10% of their weight, their energy requirements would go down by roughly 170 to 250 calories a day, which means this is the degree of behavior change we're going to need to do to keep the weight off, right? You have to do it forever. This is to maintain down here. You have to fill that gap. If it's 20%, it's even greater. What our work and work of John and others suggest is the more you fill this gap with physical activity, the more likely you are to keep the weight off. Now, it's difficult increasing physical activity. We see this in our data set, the National Weight Control Registry, where 92% of these people that are maintaining a 70-pound weight loss essentially are doing high levels of physical activity. It is possible to do this with diet alone, but even reducing energy intake by 200 calories a day is not trivial. So the more you can do it with physical activity, the more sustainable it is. Because when you do it with diet, you're really opposing these biological mechanisms of hunger, and it's very difficult to do. And John will talk a little bit more, but it's the point where we tell people in our programs, if you're not prepared to substantially increase your physical activity, you're not very likely to keep your weight off. So should we tell people to exercise? Well, if we add physical activity, I think there's pretty good evidence that for most people, they're going to lower body fat mass. There are individuals who won't, but the majority of data suggests that most people will. If you look at what physical activity does on the output side, it increases energy out, increases all the oxidation, protein and carb, but particularly increases fat oxidation or the capacity for fat oxidation. And lots of studies that show this. On the intake side, maybe you do compensate a little bit. If you're down in the unregulated zone, it's likely that you may compensate some. Some people will compensate not at all. Some people will compensate a little bit. If you're up in the regulated zone and you add exercise, nothing may happen because you may be better able to compensate. So we should look at the subjects that we do our studies on. But the bottom line is everything we know about the science of energy balance suggests that adding exercise is going to positively affect body stores, energy expenditure, and that compensation, while there may be a little bit, is not complete. Bottom line is, yes, it should affect body weight and body composition, unless you're in that regulated zone. And these are the athletes where they're pretty good compensators, but they don't have a problem with excess body fat to start with. Now, one of the things that I think we have to do a better job is not segregating physical activity and energy intake. Nutrition and physical activity are two sides of the coin, and we can't understand one without the other. And one of the things that I think about a lot is the best diet for an active, fit person the same as for an unsedentary fit person. How many people think those two are the same? Just curiosity. Okay, so you think it may be that a physical activity, active person may be different. So if this is the American population here, sort of your mid-sized sedan, the question is, where do we get information about that? If you're in the car industry, interestingly enough, most of the technology comes from the really high-end cars. And it filters down to, that's where airbags and all this stuff started in the really high-end cars. And it filters down to these. Now, the next car, this is Bill Cole's current car. He gave me a picture of that. Thanks, Bill. And I think part of the problem with what we're doing in the obesity field is we're actually studying this and making recommendations here based on this. So I really think we have to get the physical activity people with the dietary guidelines together with the the food people with the dietary guidelines, physical activity people with physical activity guidelines, because I think it's not one size that fits all, and I think we can't do it alone with diet or with physical activity. So again, here's one of my colleagues who studied the Garmin riders at the Tour de France. Their total energy intake was 6,000 to 9,000 calories a day, 75 to 80% of carbohydrate. They were eating 1,000 grams a day of simple carbohydrate, 400 grams of simple sugar. Now, I'm not saying you should do this, but if you're at the level where you're burning calories like that, the recommendation for sugar intake may be a little bit different. If we're going to take on sugar or fat or some of those other nutrients, I think we have one hand tied behind our back if we're just looking at the intake side. We've got to look at the oxidation side as well. So maybe if we got everybody to ride the Tour de France, we would be okay here, but that's not likely going to happen. So here is, I think, the bottom line. If the line here is achieving energy balance at a low level of body fat mass, you have to interact with diet and physical activity. So here are the Tour de France guys up here. If you're going to be that active, at least for obesity, body weight, doesn't matter what you eat. You can eat anything you want. Now, we could talk about performance, but from a body weight point of view, you can eat anything you want. It's a very tiny number of people up here. Down here, that's the 8% people in our National Weight Control Registry. They're maintaining a reduced weight totally with diet because they're very vigilant on every single morsel coming through. Again, this is a tiny part of the population at the extremes. For most people, it's going to be that interaction with physical activity and diet. The more physically active we can get people, the more lenient, if you would, on dietary intake. It's very difficult to do both. I'm not saying it's easier to promote physical activity than changes in food intake, because with food intake, you're opposing a strong biology that says eat ED. You're opposing a strong environment that says eat ED. With physical activity, you're opposing a strong environment. I think the biological opposition might not quite be as great. So there might be some advantage in promoting physical activity. But the bottom line for most of the population, unless you're going to get people up here or make them be very vigilant, our only hope is to be able to modify both diet and physical activity. Now, finally, just to finish in a couple of slides, if we choose to focus on a food alone, what do we miss? We miss all the other aspects of physical activity. And I don't know that we're going to hit a lot of these in this conference, but it's important to know that physical activity does way more things than regulate weight. Cognitive function, depression, national security, economic growth. There are a lot of other reasons to promote physical activity other than just weight. Now, I asked my friend Steve Blair, what's the one thing you could most do to improve human health? What do you think Steve said? Increase cardiometabolic fitness. So it is very important that we do that. If we've got everybody in the regulated zone, unregulated zone, it's very unlikely we're going to solve obesity with food alone. We have to get them in the regulated zone, but we're going to have to deal with both physical activity and food. So I think our real challenge is how do you get people to move? I think the science of energy balance strongly suggests that adding physical activity prevents weight gain, decreasing physical activity promotes weight gain. So the issue is, how do we get people to do that? Because we haven't been very effective. I'm happy to see that a good part of today's program is on doing that. Focus on the environment, focus on behavior. Why do people want to change? We have people that come in our clinic and say, I want to lose weight, but I don't really want to change my diet, and I don't want to exercise. We have to give people a pretty powerful why. What if it became policy that in every workplace, employees get 30 minutes of physical activity on the clock every day? I think that alone would make an impact. In school, every kid comes home from school, 60 minutes of physical activity. These are the things we need to explore. I'm really excited that we got some great speakers to tell us some of this. So in conclusion, I think studies of energy balance strongly suggest changes in physical activity are directly related to changes in body weight in most people. The biggest impact of physical activity may be in changing the active regulation of energy balance. Increasing physical activity should be an effective way to prevent and treat obesity. Our biggest challenge remains how to permanently increase physical activity. We cannot reverse the obesity epidemic without increasing physical activity in the population. Thank you very much.